and 4 states. So how do we put in the values for our regret matrix? So let's look at here. Suppose you choose decision D2. Okay? Suppose you choose decision D2. And state S1 happens. Okay? Suppose you choose decision D2 and then you find out, oh, there's a recession tomorrow. Okay? Do you have any regrets? So you choose D2. And then you find out the next day, oh, state S1 happens. Do you have any regrets? You have no regrets? You did the best thing? Okay, you choose D2, and then you find out the next day, oh, state S2 happens. You know, Donald Trump put on the tariff. Okay, do you have any regrets? Yes. If you had to put a dollar amount to that regret, how much dollar would it be?
2.
2. Right? Because you choose D2, so you got $2 profit. But if you choose D1, you would have got 4, right? So therefore, the difference is your regret. So you would have a regret of 2. How about if state S2 happens? Do you have any regrets? Yes. How much? 6, right? You could have went with D3 and you would have made 8, but now you only have 2. If state S3 happens, no regrets, right? You did the best thing possible if state S3 happens. So you would have no regrets. And finally, if state 4 happens, again, you're equal to D1 and you're better than D3 and 4, right? You're equal to D1 and you're better than 3, 4. Again, you have no regrets. So basically, you say, if I make this decision and this state happens, did I did the best thing? And if I didn't, what's the difference that I could have made? Okay? Can you fill in the other numbers? Okay, so we choose D1 and state S1 happens. We did the best thing possible, so no regrets. If state S2 happens, we have a regret of 4. If state S3 happens, we have a regret of 2. And if state 4 happens, we have no regrets. And then I'll just fill in the other values. Okay, any question on the regret values? Then we're going to, for each decision, pick the worst regret. So the worst regret here will be 4, here is 6, here is 4, here is 2. And so this here would minimize the maximum regret, right? So we would basically choose E4 to minimize the worst regret. So these are the 4 common decision-making strategies that you'll find in any textbook on decision-making. Now we're going to assume the states have probabilities. Okay, we'll assume the states have probabilities, and so we would simply be choosing the decision that maximizes our so-called expected value. Okay, so in this problem here, we have 2 decisions, 3 states with some probabilities, and then over here, the amounts are cost. Okay, so it's not payoff, the amounts are cost. So which decision are we going to choose? Are we going to choose D1 or are we going to choose D2? So we calculate the so-called expected value. So 0.5 times 2, 0.3 times 7, 0.2 times 3. So it gives me an expected value of 370. And over here, the expected value is 320. I'm hoping with a new prime minister, relationships with India and especially China would improve significantly. With the current Trudeau government, they really soured the relations with China and kind of really, hurt the Canadian economy and the universities. Less visa students coming over and so on. It's really bad. Okay, so which one are you going to choose? Because this is cost, you would choose the lower cost one, right? Because this is cost, you would choose the lower cost one. So you would choose D2 for lower cost. And we're not exactly friends with the US right now. And you may have heard this saying before, the enemy of my enemy is my friend. Okay, next we want to calculate something called the expected value with perfect information, or shorthand by textbooks EVWPI. Is that suppose your friend has a crystal ball and can tell you what's going to happen tomorrow or which state will turn up. So how much are you willing to pay for this so-called perfect information or crystal ball? Right? So first you have to calculate what is your expected value if you have the crystal ball, and then you can decide then how much you're willing to pay. So first we calculate the expected value given we have the perfect information. So we have the probabilities here, we have the states. And then we will list our decisions and corresponding cost. so let's have a look. So you look at the crystal ball, and the crystal ball says, okay, state S1 is going to happen tomorrow. What are you going to do? Are you going to choose D1 or are you going to choose D2? Okay, you look at the crystal ball, and the crystal ball says, okay, state S1 is going to happen tomorrow. What are you going to do? Are you going to choose D1 or are you going to choose D2?
D1.
D2?
These are cost.
Oh, it's cost. Oh.
So you choose D1 for the lower cost, right? How about if the crystal ball says state 2 is going to happen? What are you going to do? D1 or D2? You would choose D2, right? For the dollar, right? How about crystal ball says state 3 is going to happen? D1 or D2? D2 as well, right? So depending on what the crystal ball says, then you make a corresponding, appropriate decision and results in appropriate cost, right? And so what's the expected value here then? Well, you got your 0.52, 0.31, 0.22, so the expected value here is $1.70. So if you don't have the crystal ball, your cost is $3.20. If you have the crystal ball, your cost is $1.70. So the difference is how much you're willing to pay to have that crystal ball or perfect information. So therefore, we'll pay up to $3.20 minus $1.70 equals $1.50 for the perfect info. Also, this $1.70 is what we call the EDWPI. Okay? This $1.70 is what we call the EDWPI. Let's talk a little bit about risk. It says using the expected value to make the decision does not consider the risk of the decision. Because the expected payoff is like an average payoff, it's not the actual money you get at the end. Okay? It's not the actual money you get at the end. So here we have two decisions, and depending on whether there's a recession or boom, you get the corresponding payoff. And so what decision are you going to choose? Who likes A? Who likes choosing A? One. Okay, so the rest of you is going to choose B, right? So I have a very conservative class of students I see. Suppose you went with expected value, see what happens, right? So you got 0.4, 10, 0.6, 10,000. So here is 6004, and here is 3600. So if you went with expected value, you choose A, right? You choose A. So we would choose A for best expected value. But as I said before, expected value is like an average, right? It's not the money you get. You don't really get $6,000. You get either $10 or $10,000, right? You don't really get, it's an average, so it's not like an amount you actually end up with. And I'm gonna guess that most of you are not choosing A because A is risky. And you might remember that risk is kind of an individual thing, right? For somebody who has $1 million in their bank account, A is not risky, right? So it's a personal thing, right? So I would choose B. And in the book, it tells you that, okay, you can use utility theory to calculate the expected utility. Which incorporates risk in making the decision. And I know that from the past, students has told me that you kind of use utility theory to calculate expected utility in making decisions. And as examples, should you buy like home insurance or not, or earthquake insurance or not? And I can even see here, in your economic class previously, Professor Iris Allen's room, you got risk premium here, right? So that's basically using utility theory. So we will be covering that in this course. Next, we want to perform some sensitivity analysis. We can perform some sensitivity analysis on the state's probabilities. We can perform some sensitivity analysis on the payoff values. So first, we look at sensitivity analysis of the state probabilities. So this examines how changes in the probability of the states affects the recommended decisions. So here we have 3 decisions, and we have the 2 states, and then P is the probability of state 1, and 1 minus P is the probability of state 2. So we want to know what are the values of P such that D1 is the best, or what are some values of P such that D2 is the best. And finally, what are some value of P such that D3 is best? Okay, so this is what it's talking about, right? What's the values of P such that D1 is best? What are the values of P, D2, and D2, right? So we would need to calculate the expected value of each decision and compare. Okay, we would need to calculate the expected value of each decision and compare. So the expected value of decision D1 is P times 8, and then 1 minus P times 7. And we can simplify that to P plus 7. And then similarly, expected value for decision D2 is 14P, and phi 1 minus P simplifies to 9P plus 5. And then finally, D3 here. So to find this range here, we have to make a plot. Okay, we have to plot expected value of the decision versus the probability P. So we put this on the y-axis and we put this on the x-axis. To make a plot, we need 2 points because probability goes from 0 to 1. So maybe that's the easiest thing to do. So if P is 0, then ED is equal to 0 plus 7 or 7. And on the other hand, if probability P is 1, then ED is equal to 1 plus 7, which is 8. Same thing, if P is 0, then ED is 0 plus 5. If P is 1, then ED is 9 plus 5. Okay, if P is 0, then we have minus 9. If P is 1, we have 20. So now we're going to plot then. So P goes on this axis, and then expected value of the decision go on this axis. Alright, so let's start plotting here. So for expected value decision 1, we have 0, 7. And 1, 8. And then for line 2, we have 0, 5 and 1, 14. And finally, we have 0 minus 9 and 20. Okay, so let's see what are the values of P for each decision to be optimal. So basically we're looking for the highest expected value here. So it looks to me like from 0 to about this point over intersection here, this is the highest. So that would correspond to decision D1. So basically from 0 to wherever this point is, D1 is the best, right? D1 is the highest or best. And what is this point here? Well, this point is where decision D1 is equal to decision D2. Decision D1 is P plus 7, and decision D2 is 9P plus 5. So that's just coming from here. And so solving, you get P is equal to 0.25. And then looking at from here to about there, this top decision is the highest or best, and that corresponds to D2. So from there to there, that's the highest D2. So what is this point here? Well, this point is the intersection of ED2 and ED3. And so we get 9P plus 5 is equal to 29P minus 9. Get us P equals 0.7. And finally, from this 0.7 to 1, this decision seems to give me the highest payoff. And so basically, now we know when P is from 0 to 0.25, D1 is best. And then between 0.25 to 0.7, 2 is best. And finally, from 0.7 to 1, 3 is best. Okay, any question on this problem here? Sensitive analysis, figure out ranges for probability for state one for each decision to be optimal. Okay, next we want to perform sensitivity analysis on our payoff values. It says in most practical situations, the payoff or cost values are just estimates only, and so there is a chance they can end up being higher or lower. So you might want to perform some sensitive analysis on how high or low payoff can go for you to keep your current decision. Okay, so in this example here, we have 3 decisions, 2 states, and probabilities. So to begin with, which decision are you going to choose? Well, we would calculate the expected value, right? So whoever has the highest, so that's this one here, we choose that, right? So simple problem here, we choose D3, right? So now we're gonna perform some sensitivity analysis here. Okay, so we have here probability, states, and then there is our decision here. So we'll let this be A, this be B. Maybe put in the original values here for reference. So originally this is 20. This was -9. So expected value then is 0.8 times A plus 0.2 times B. Okay, so now we see that D3 is still the best if this 0.8A plus 0.2B is better than the next best decision, which is 12.2, right? If it's best by the next best decision, which is 12.2. So we will first fix B to be equal to the current value of -9. Okay, we'll fix B the current value of -9. And so 0.8A plus 0.2 minus 9 bigger than 12.2. Well, gives me A needs to be bigger than 17.5. So we don't have to make $20, okay? But we have to make at least 17.5 for us to still choose D3. Okay? So we don't have to make $20, but we have to make at least 17.5 for us to still choose D3. How about if we fix A to be 20? Then we have this 0.2b greater than 12.2 gives me B needs to be bigger than minus 19. So here we don't have to lose $9. We can lose up to $19. Okay, we will lose up to $19, and we will still keep our decision D3. Okay? Finally, we have something called a dominance concept in decision making. It says person A dominates person B if A is better than B in every way, right? Stronger, smarter, whatever, right? Similar idea, decision A dominates B if A is better than B no matter what happens, okay? No matter what state turns out. Then we can remove the dominating decisions from consideration. Okay. So here we have 4 decisions, 3 states, and it says which decision do we not need to consider because it's dominated by others. Do you see? Is decision B1 dominated by some other decision? By which one? By which one?
3.
By 3, let's see. If state S1 happens, D3 is equally good. If state S2 happens, D3 is better. If state S3 happens, D3 is better. So D3 is either equally good or better, right? So D3 dominates D1. So we can remove D1. How about D2? Does D2 get dominated by some other decision? Does D2 get dominated by some other decision? Yes? D4. So if state S1 happens, D4 is equally good. If state S2 happens, D4 is better. If state S3 happens, D4 is better. So D4 is either equally as good or better than D2. So again, D4 dominates D2. And I think that's it. So basically, there are only 2 decisions to make. So before making decisions and solving the problem and so on, you should kind of screen for some dominance. I thought I would have a lot of time left over, but I guess I don't. I was going to give you a little goal programming exercise, but you can work on it now. And then if you have difficulties, you can ask me during office hours or whatever. Okay, so you can take the last little bit of class time here and see how far you get on this goal programming problem. Yes? No, it's state as what happened, these reads all three, no matter what. Better than it, no matter what. Okay, so please work on this little goal programming exercise here. Any extra sheets lying around?